Okay. All right. So number of gallons of olive oil in a tank at time t is given by the twice differentiable function a, where t is measured in hours. Values of a of t at selected times are given in the table above. So a says use the data in the table to estimate the rate at which the number of gallons of olive oil in the tank is changing at time t equals 10 hours. Show the computations that lead to your answer. Okay. So when we're talking about a rate, we're not given a rate here. This is just hours and the number of gallons. So if I want to know the rate, we don't have to go as far as to use mean value theorem here, but it's sort of related to the mean value theorem. So slope formula, the slope of a line is going to give us our rate that we have at 10. So if we had an equation, we could use the derivative to find that. But it doesn't give us an equation. So all we can go off of is the table that's given here. And 10 would fall between 5 and 15. Right? So the best we can do when we're only given a table to estimate this rate is just to do slope using those 2 points. So we're using the point 5, 18 and 15, 25. Okay. So if we do the slope formula, we'll do 25 minus 18 over 15 minus 5, which will give us 7 over 10. You can leave it 7/10 or you can do 0.7. And it doesn't specifically say right here, but in AP questions, typically, if they give you units, you need to put units on your answer. Now, this one in particular doesn't ask for the units. A lot of times they will, so that may or may not have a point for units on it, but a lot of times it does. So just to be in that habit, what would the units for this rate be? Gallons per hour. So whenever we take a derivative, we're finding slope. So it's always changing y over changing x. So your units are always y over x, right? Gallons per hour. All right, so our estimate here is that our rate of change is about 0.7 gallons per hour. They're not, no, they're not too picky about it. I never said like anything that tells me this has to be the average, so it's probably okay to have equals here, because it is true that all these are equal, but like if you did something like a prime of 10, you don't have to do this, but if you did write something like a prime of 10, which is the slope at 10, to be correct, you would need to do the approximate symbol there. But I don't think it would really be required here. And I think that they're lenient on that anyway. If you do it equal when you should do approximate, they don't take the point away. All right, questions? All right, for 0 to 30, is there a time t at which a prime of t equals 1/5? Justify your answer. Okay. If they tell you to justify your answer, it's probably a yes. It's not always, but it's probably a yes. And so, is this intermediate value theorem or mean value theorem? Okay, how do I know it's mean value instead of intermediate? Because you're looking at the derivative right here. Let's see what we got here.
Yeah, I've been recruiting everybody. You know I got to worry about that. Yeah. I got it. Yeah, you're jumping out of here. Y'all are doing good. All right, get out of my class now. We're doing exactly. Loser. Good job.
Ethan, your people are... If you want to give blood, make sure Ethan is the one that gets to sign you up and not our
Does
other.
everyone know all the information? I'm going to sign up. Okay, good. Let's get back to calculus.
Okay. Alright, so if this said A of t equals 1/5, it would be intermediate value theorem. But since it's A prime, its derivative, then that means that it's mean value theorem. Yeah, I kind of do too. It's less work. Alright, so mean value theorem tells us the slope between the endpoints has to equal the derivative. What has to be true for us to use mean value theorem first? Continuous and differentiable. So, A of t is continuous and differentiable. Yeah, you could take a second derivative of this also. But if it's twice differentiable, it's also just regular differentiable also. There might be a part coming, I can't remember if there is, where you need to look at the second derivative. And if that is the case, then they have to tell you that you can take that derivative twice. On the interval 0 less than or equal to t less than or equal to 30. Okay, so once we have established that this is continuous and differentiable, we need to find slope through the endpoints, and it has to equal, hopefully, 1/5 at some point, all right? So be careful on this one, because what interval are we looking at? No, 0 to 30, not 0 to 35. So be careful. We're using the points 0, 10, and 30, 16. And so that is going to give us 16 minus 10 over 30 minus 0. So we get 6 over 30. And if we divide both of those by 6, we'll get 1/5. Thank goodness we get 1/5, because if it wasn't 1/5, we could not prove that anything happens here. It usually is going to be the number that you're looking for. So we can say, therefore, by the mean value theorem, A prime of t equals 1/5 for some t on 0 less than or equal to t less than or equal to 30. You can't actually find that point because you don't have an equation. It doesn't ask you to. It just asks you to justify it has to equal that at some point. Yes. If it didn't work, you would want to check and make sure there were no other points on this interval that gave you 1/5. So, for example, like if between 5 and 15 you got 1/5, or 15 and 30, or maybe 5 and 30, you got 1/5. If it was anywhere in that interval, then it would prove that it is also 1/5 on that interval from 0 to 30. But I have never seen a problem where they did that. It's always been the endpoints, and it's always been that value whenever I've seen these. I don't recall one where the answer is no. The answer is usually yes for these. Now, there could be one. And they love to put a curveball on there, so don't make that assumption. But if you find out that it is no, you should be like questioning yourself and making sure you didn't make a mistake. So, yeah. All right, questions on A or B?
Nope.
All right, C. The number of gallons of olive oil in the tank at time t is also modeled by the function g, defined by this long equation here, where t is measured in hours, between 0 and 35. Based on the model, at what time t from 0 to 35 is the number of gallons of olive oil in the tank an absolute maximum? Justify your answer. So, we want to know absolute maximum. To find an absolute maximum, what do we do? Derivative, set it equal to 0 to find critical points, right? So, g prime of t, this is going to be a 5. What is 2/3 times 3/2? 1, thank goodness. T plus 9 to the 1/2 times the derivative of the inside, but what is the derivative of t plus 9? It's just 1. Just 1, so it goes away. What's the derivative of 28? 0. So derivative's not that terrible. It could be way worse. I'm going to change this back to a square root right here. You don't have to do that. So if we set that equal to 0, we got, where have you got 3? Can't do that because there's a plus sign there. If it was 9t, you could do that, but the plus sign, you can't do that. So we're going to move the square root over to the other side, so we'll get t plus 9. We will square both sides, so we get 25 equals t plus 9, and then we'll subtract 9. And so we're going to get 16. So our critical point is 16, which does fall between 0 and 35. This asks for absolute maximum. So an absolute maximum, we've got to check the endpoints, plus we've got to check 16 to see which one is highest. Plug into the original. So we'll do g of 0. That's our first endpoint, which is going to be 5 times 0 minus 2/3. I'm going to write this as the square root of 0 plus 9 cubed plus 28. Yes? That's a good question. I think A, number of gallons of olive oil in the tank. I think it's going to give us it may give us a different answer. So we're going to get 2/3. Look, do not do 9 to the 3rd. This is the square root of 9 times 9 times 9. Which is 3 times 3 times 3, which is 27. And so you could reduce here. You end up with 18 plus 28. So we get 46. Oh, it is negative. So you get 10. Alright. I definitely did not leave you enough room to do this problem. So, we got 16 coming up. I'm going to put it down here, even though it really should be up there. If you need to use an extra sheet of paper or something, that's okay. Bathroom pass. Alright, it's 90 minus 2/3. This is the square root of 25 to the 3rd plus 28. All right. All right, this is going to be 5 to the third power, which would be 125. Oh, gosh.
That's why I'm just going to trust the number they give me.
250 over 3. Was this a calculated inactive problem? I thought it was. We're going to use the calculator because we don't have time to do this. This was from AP Classroom. I can't remember. Maybe it was calculator active and I forgot to put that next to it. But all right, let's.
I signed up.
Okay. 5x. You guys know you can do this whenever, if you are using the calculator for this, which I didn't think this was calculator active, but I'm remembering now that, I'm seeing now that I don't want to do this without it. If you type this into Y1, guys, quiet. If you type this into Y1, then when you go to this main screen, you can just type in Y1 of 0. And it'll give you 10, which we had already found. You can do Y1 of 16, which gives us 72 over 3, or 24.6667. And then we can do Y1 of 35. Oh, good gracious. Hit that green button before you hit enter. I'm feeling like this was not, maybe it was calculator active. All right, so, I hope. So, surely it had to be calculator active, I think here.
I would just listen to the chart there.
Which is A, not G, so.
They did have the same numbers, though, other than 35.
Yeah, they did. So we would just say G of 16 is 70, what was it, 74 over 3? 4 over 3. And we'd say G of 35. So if this is calculator active, you do not have to show that you did this. 8.42. 5. And so we would so whenever you are doing absolute maximums and minimums, it's on a closed interval. You don't have to say there was a switch or anything like that. You have proven it by showing that at 16, you have the highest number. So you don't have to write a sentence here. You can do some long division there if it was calculator. I think this would have to be calculator active, and I forgot to put it down. So, we're not worried about it. All right, so we would need to say, it says based on the model, at what time t is the number of gallons in the tank an absolute maximum. So, we would say at 16 hours, the amount of oil is an absolute maximum. Okay. Quiet, please. All right, so for D, it says for the function G defined in part C, the locally linear approximation near. No, we ran out of room, so I put some stuff down there, but we haven't looked at it. Okay, I just ran out of room. All right, so for the function g defined in part C, the locally linear approximation near t is used to approximate g of 8. Is this approximation an overestimate or an underestimate for the value of g? Give a reason for your answer. So we have not done this yet, so that's why I wanted to make sure that we did this problem together. So locally linear approximation, this is something we did it a little bit out of order is the reason we haven't seen it. So this is the idea that if I have some sort of function, I don't know what this looks like, if I have some sort of function, then let's say that right here at 7, I have a tangent line. But for some reason, 8 is really hard to plug in, or I don't have the information I need for 8 there. So if I want to find the value of the function at 8, but I don't know how to do that with the equation, or it's really complicated to find that with the equation, I could just plug 8 into my tangent line and get this point right here. And you can see as long as you're pretty close, that's going to be a pretty close number. Now if I use it to approximate something way out here, it's going to be way off. But if I use it right here, it's going to be pretty close. So the idea that we have here is we want to know if this is an overestimate or an underestimate. 7 is where your tangent line is at. 8 is where you're finding the estimate. So it could look a couple different ways. Well, actually, there's 4 ways that it could look. So let's say we got 7 here, 8 here. It could be increasing in concave down. Okay, if that's the case, if it's increasing in concave down, the tangent line right here would be the actual value for 8. Right here would be your approximation, so you'd have an overestimate. Right, so the actual value for 8 would be on the curve. The estimate you would get from the tangent line would be above. Or it could be increasing concave up. It could look like this. So if we have a tangent line at 7 for something like this, then actual value is what's on the curve right here. You would if it asked you to find the approximation, but it doesn't for this one. It just needs to know whether it's an over or underestimate. So we would see, here we get an underestimate. We could have decreasing concave down, look like this. Tangent line at 7 would be here. Here's our actual. Here is our estimate. I'm going to erase this over here so I can put the other option. And then we'd have 7, 8 here. And so we could have decreasing concave up. Could look like this. So tangent line would be here. Actual estimates. Okay, so this was decreasing and concave down. This was increasing and concave down. No, I'm kind of teaching this to you as I'm showing you this problem. So this is you would not need to draw all this. You would be increasing and concave up here. You're decreasing and concave down here. Hold on. This is an increasing concave up. Decreasing concave up. Concave up is the curvature. So if it looks like a U, either side of the U is concave up. If it looks, it's concave down. So, if I have this situation, this is an underestimate. Because the green dot there is my estimate. It's below where my actual value is at. If I have this situation, this is overestimate. Here we have a underestimate. Yeah. We're looking to see where the green dot is above or below. And this is an over estimate. All right, so what matters, increasing and decreasing or concavity? Concavity. So if we are concave up, if we have something that's concave up, then we are going to have an overestimate even if it's increasing or decreasing, right? If it is concave down, it's going to be an underestimate. Now, you need to know this because it is something that you'll see. I'm teaching this to you as we go, right? You haven't seen a problem like this before. No. All right. So, I was answering Daniel's question of it being a 50-50. All right, so this stuff you wouldn't need to write. I'm teaching it to you as we go. So I'm going to insert a blank page here so that I've got some room to write. I realize you can't do that. But, so I need to know the concavity of this because it will tell me whether the tangent line lies above or below the graph, right? So what do I need to know to find concavity? Second derivative. I already found the first derivative up here, which was 5 minus the square root of t plus 9, so g prime of t. This is the part you would need to write down. 5 minus t plus 9 to the 1/2. So when I take the derivative of this, I'm going to have negative 1/2 t plus 9 to the negative 1/2 times the derivative of the inside, which is just a 1 here. So I would probably move this back down to the bottom. So you'll have 2 square root of t plus 9. This is your second derivative. You are going to set the numerator and denominator equal to 0. But the numerator, are you going to get anything? No. So it's only the denominator really you're worried about. Was it a minus? It was a plus. All right, now, let's think about this situation. Our value that we get here is negative 9. We're talking about time. And we're also restricted to 0 to 35, right? So, that doesn't even fall on the range of what we're looking at. What that tells me is that this second derivative probably has the same sign for 0 to 35, right? Because my critical point is the only place it could switch, right? Right. So, and since it's not there, then it's got to either all be positive or all be negative. So you can still make a sign line if you want and use negative 9, but what we're asked about is 0 to 35. So it's really whatever sign we have over here is going to be the sign that we see for that second derivative. So if you plug in 0, then you get negative 1/2, or let's use this. So we get negative 1 over 2 times the square root of 9, which would be negative 1/6, so you get a negative here. So we would say since g double prime of t is less than 0 for the entire interval that we're looking at from 0 to 35, we would say G is concave down. So the estimate is, and here's where I always have to draw myself a little picture. If I've got concave down, doesn't matter whether it's increasing or decreasing, tangent lines are going to be above. So it's an overestimate. Yes. Yeah, these are common. Yeah, finding the estimate is usually part of the question. They usually have you find the actual estimate first and then tell if it's, yeah, so it's usually on FRQs, and it's usually like in part B, you found the estimate. This one, for some reason, didn't actually have you find the estimate, but, which we will do in more depth here, but this relates to concavity. Okay. Okay, so this, have we got the idea here? Concavity is related to whether or not your tangent would be above or below the graph, right? So we're okay with finding the second derivative and finding concavity. Okay, so you find the second derivative, you do a sign line, you tell whether or not it's positive or negative, and that tells you concavity. So what is being added to that here is that if a function is concave down, the tangent line is going to be above, so a tangent approximation, or they call it a local linear approximation here, locally linear approximation, which is sometimes it's called a tangent line approximation. The tangent line, if the tangent line's above, it's an overestimate. If it's below, it's an underestimate. Okay. All right. So, I want us to do. I actually want us to do this one next. And I'm going to give you guys that one that the other one there. You guys are going to finish for homework because it's similar to this problem. I want you guys to work on this one right now. It's also, these two FRQs are homework. If we don't get them done, because we've only got 2 minutes left, but right now I want you to work on it. I'm not putting it online. You guys are relying on them too much. Try something on every problem. If it's not right, it's okay. We'll go over them. Yes, I did record that one. Actually, I think I did. Yeah, so this and the second FRQ on that worksheet are going to be your assignment, and I need you to work on it right now. You have 9 minutes. Do not waste them, because we were wasting way too much time in this class. For sure.